Welcome to this video on staying safe working on or around electric vehicle batteries. My name is Jeff, and this is Suganti.
Hi, in this video we'll start by going over a few electric vehicle battery basics.
We will look at the three primary hazards that you should be aware of: electrical, fire, and chemical.
We will also highlight a few other important hazards such as unintended movement and material handling. We will conclude the video with available resources to learn more.
But before we get started, let's consider why electric vehicle battery safety is increasingly important to workers in Ontario. Canada is the only country in the Western Hemisphere with all the raw materials required for a lithium-ion battery, with Northern Ontario already being a key producer of nickel, cobalt, and copper. In the past 3 years, Ontario has attracted over $28 billion in automotive and EV investments, positioning the province as a global leader in the EV supply chain. According to a Clean Energy Canada report, the battery electric vehicle supply chain will support upwards of 250,000 jobs by 2030. And up to 100,000 auto workers in Ontario will need to be re-skilled to support work in this sector. For Ontario auto collision centers, repair shops, auto recyclers, and other impacted businesses, a key component of this reskilling involves being able to recognize and mitigate the health and safety hazards working on or around EV batteries. And that starts with identifying fully electric and hybrid vehicles.
Hybrid vehicles may be difficult to spot because in many cases they share a platform and look almost identical to their gas-powered counterparts. However, an EV or hybrid will often have a green or blue badge somewhere on the vehicle. A plug-in hybrid and battery electric vehicle will have a charge port. However, a standard hybrid will not. And once you get under the hood or in the panels, you will find orange cables. These are the high-voltage cables.
Before we start discussing cables, however, let's break down the components of an EV battery. The main components in a lithium-ion cell are the electrodes, the anodes and cathodes, the electrolyte, and the separator. The electrodes are the positively and negatively charged ends of a cell and are attached to the current collectors. The anode is the negative electrode, the cathode is the positive electrode. The electrolyte is a liquid, or more commonly, a gel, that conducts the electricity within the cell. And the separator is a porous film that separates the electrodes while enabling the exchange of the lithium ions from one side to the other. In a lithium-ion battery, the lithium ions move back and forth internally between the anode and the cathode while the electrons travel through the relevant device, in this case, the electric vehicle that's being powered. While the battery is discharging to power the vehicle, the anode releases lithium ions to the cathode, generating a flow of electrons. When the battery is charging, the opposite's occurring. Lithium ions are released from the cathode and received by the anode. Each lithium-ion battery cell is connected in series or parallel to form battery modules, and then these modules are connected together to form a battery pack. The battery pack is then installed into the vehicle and contains the battery monitoring system.
Knowing what EV batteries are and how they work helps understand the hazards to be aware of when working with and around them. The first hazard we'll discuss is the obvious one: electrical hazards. EVs have both low and high voltage systems, and in the case of high voltage, this can exceed 800 volts. It is critical for anyone working in or around EV batteries to de-energize the system before doing any work. This will vary from vehicle to vehicle, so review the manufacturer requirements for de-energization and lockout-tagout. Remember that de-energization and hazardous energy control are not the same. Pulling a high-voltage plug or fuse out is not adequate for hazardous energy control. Lockout-tagout is still required.
Also, all workers must have proper PPE before working on or around an EV. Proper PPE includes high-voltage gloves, Class 0, 1000 volts, with leather overlay, safety glasses and/or shield and/or arc flash clothing.
Required equipment also includes a Cat 3 multimeter, insulated tools, and safety barrier tape and signage. The next hazard is fire and thermal runaway.
A thermal runaway event can be triggered by damage to a battery cell, either as a result of an internal or external short or external temperature. When one of these faults elevates the cell temperature, the materials inside begin to break down and can trigger an exothermic reaction. As the temperature increases, so does the decomposition rate, which causes rapid heating of the cell and can lead to a fire or explosion. This reaction may spread to nearby cells and modules, intensifying the event. There are many potential causes of thermal runaway, but the most likely cause is due to collision damage to the vehicle. Less likely causes include manufacturing faults either in the battery cells or the module or the battery assembly, and another possible cause could be overcharging or discharging. And while this typically is not a concern with modern EVs, modifications to the battery or BMS may make this possible. After caused by, for example, a collision, a thermal runaway event may take minutes to days to even weeks for an event to begin. Early warning signs may include noise such as a hissing or popping sound, a rise in temperature, and gas production. A chemical cloud may also be produced, resulting in potential exposure to toxic and flammable chemicals, which brings us to our third hazard, chemical hazards.
The electrolytes used within the batteries will vary between manufacturers, but in general they will be corrosive, flammable, dangerous, and toxic. In most cases, though, after manufacturing, the chemicals will not leak from the batteries without a thermal runaway event occurring. So typically, if a battery is damaged to this point, the greater concern is thermal runaway versus the chemical hazards.
Those three are the top hazards to look out for, but there are a couple more I'd like to share. One is the hazard of unintended movements, which is when a vehicle moves on its own. There is a potential for unintended movement due to the proximity key being left in the vehicle, or due to a potential short circuit within the system. Also, a lot of electric vehicles have apps that can control them from the owner's phone, so this is something to keep in mind when working on them. The final hazard we'll mention is one that can precipitate and exacerbate all of the previous four hazards: poor material handling. Electric vehicle batteries, and hence the vehicles, are very heavy. Lifting devices must be rated for the weight of the vehicle, and lifting point placement is especially important because they are often very close to the battery and at times may require different adapters to prevent damaging the battery in the frame of the vehicle.
That concludes our video. To wrap up, here are some tips to staying safe when working on or around battery electric vehicles. Tip number 1, ensure that you have and review the manufacturer information. Every vehicle is different, so before you even get started, be sure you have the correct information on hand to reference throughout the work.
Tip number 2, have a clear lockout procedure and ensure that you and everyone involved adheres by them.
Tip number 3, be aware of potential early warning signs of thermal runaway.
And tip number 4, have a thermal runaway emergency response plan. In the unfortunate and unlikely circumstance that there is a thermal runaway event occurring, or there are early signs such as a highly toxic flammable gas cloud, do not go near the car or the batteries. Stay clear, evacuate the area, and call 911.
The good news is EV fires are very rare. So let's all embrace electric vehicle batteries and be safe while doing so.
At WSPS, we have some additional resources that you can use. A white paper with some very important and useful information, accessible on our website and through this QR code. Another resource is our electric vehicle battery hazard checklist that you can use to identify hazards and determine whether it is applicable to your workplace. The checklist is also available on our website for free. Access through this QR code. Thank you for watching this video. Contact us for more information.